Hi, welcome back to AP Physics 1, Unit 6, Simple Harmonic Motion. So this is going to be, if you're a little bit confused in the last video about what mass spring system is or what a pendulum is or how does it work, this is going to be really defining some of those terms here as well. Okay, so simple harmonic motion, or simply SHM, it's just simply the periodic motion that is caused by a restoring force. So this is the topic that we talked about in the last video. So what were these restoring forces, right? So for a mass spring system, the acceleration would be negative kx over m. And for a pendulum, it'd be g tan theta, right? And so let me write that a little bit nicer. So for a pendulum, it'd be g times tangent theta, okay? And so periodic motion is any motion that repeats itself over and over, right? So think about school, right? In school, they're called class periods. That's because after a set time, the bell rings and you change your class, right? And so that's what happens. It just keeps repeating itself. 40 minutes, or if you're on block scales, or an hour and a half, right? 40 minutes, bell rings, next class. 40 minutes, bell rings, next class, right? Block size, an hour and a half, bell rings, next class, right? That's why we call them class periods, okay? Because it's repetitive. Now, when an object is in simple harmonic motion, it's unaffected by friction and will, under these conditions continue to move. Okay? If it's not in simple harmonic motion, it's what we call damped harmonic motion. So what happens is over time, it begins to, come to a stop. Okay? You may experience this in a lab. So lab, these would be those qualitative data, right? Those general observations that you make. You may see like, hey, look, the pendulum is starting to slow down, or the mass, it's not going back to where we pulled it to, right? And so that just gives you, that would give you a real world lab setting is more damped harmonic motion than it is actually simple harmonic motion, right? And again, we've talked about, there's two main examples of simple harmonic motion here in AP Physics 1. They're going to be the mass on a spring, which could be both horizontal or vertical, okay? And then the simple pendulum, okay? The simple pendulum basically consists of a pendulum bob and a string, right? And a point of connection to something fixed, right? A fixed connection point. Okay, so let's look at an example problem. So here we have a 2 kilogram mass attached to a spring allowed to travel on a frictionless table. After it's been stretched 50 centimeters, the spring is attached to a wall, and it's going to be allowed to go back and forth without frictional loss. The spring force has a constant of 100 newtons, or the spring has a force constant of 100 newtons per meter. What is the maximum spring force, and then the maximum acceleration of the 2 kilogram mass that is attached to the spring? Okay, so here we go. We got, start with the spring force, F equals kx. So it's force equals spring constant times displacement or elongation, right? And so it's going to be 100 times 0.50, right? Because we have to convert that 50 centimeters to meters. Oh, sorry. And so the spring force will have a value of 50 newtons. Sometimes you'll see it abbreviated SP. In fact, if we're keeping with the idea that this is a restoring force, we should have negatives running around in there, right? Because that's at the 0.5 meters, it's going to be exerting, the spring exerts 50 newtons on that block to snap it back to its initial position, okay? Now, how do we find the acceleration? Well, we can set that, kx or negative kx to equal to ma. And so we know acceleration is negative kx over m. But we know what kx is. That was the 50 newtons that we saw for here in the first part. And now we're just going to do a mass. It's a 2 kilogram block. So that tells us that the acceleration would be negative 25 meters per second squared. Okay. All All right, so in the next video, so this is just looking at the mass spring system. We could have done this example with a pendulum, right? But our force and our force would be a little bit different. The restoring force is going to be that mg tan theta, and then for MA or for our acceleration is just simply going to be g tan theta. Okay, so in the next video, we're going to look at the period of swing or the period of oscillation for both of them, and then we'll talk about the energy piece.